so let's talk about absolute value. Do you guys know what absolute value is? Yes, let's see, who can tell me what's absolute value?
The distance of a given number zero.
From zero, very good. So absolute value, given a number, is absolute value is its distance from zero. That's all it is, okay? So let me, and when we talk about functions, I'm gonna give you like the function definition of absolute value. This will be our first example of what we call a piecewise function, okay? But we'll talk about that when the time comes. So let me just write the definition here, completeness. So this is absolute value. So given a real number u, let's call it u, it's absolute value. So it's absolute value denoted. So the way that we write absolute value is we put the number and then we put a pair of bars, two bars around the number like this. So its absolute value is its distance from zero. Is distance from zero. So for example, what's absolute value of 2? Gonna be 2, right? Because if you think about it, here is 0, 1, 2. So this is the point 2. The distance here is what we call 2 units, right? So the absolute value is equal to 2. Good. And then what's the absolute value of negative 2?
Also 2.
It's also 2. Why? Because you are computing distance, and the only thing is that instead of going right, you're going left now. But that's okay. The distance here is still 2. Okay? The point is that distance is always a positive quantity. Okay? It doesn't make sense to talk about distance of negative 3. What is that? Okay? Distance is a positive quantity. So when you do absolute value, to compute it is actually pretty simple. You just look at the number inside. If the number itself is positive, then the answer is itself. If the number is negative, all you do is change the sign, make it positive. You understand this? That's what absolute value is. Good. So now what we are interested in is in solving equations that contain absolute values. Okay? So we call those absolute value equations. So an absolute value equation, or let me say an equation containing absolute values is called absolute value equation. Containing absolute values is called absolute value equation. Kind of defining this. All right, so let's do a very simple example, but these two examples that I'm going to write, they will illustrate the general idea of how to solve absolute value equations. So solve, and let's do absolute value of x equals 5, and let's do absolute value of x equals negative 5. Okay, so who can tell me what's the solution to the first one? Yes?
The solution is 5 and it's negative 5.
Very good. So remember, all we're looking for is a number, a value for x, so when you put it here, this is true, right? So there are only two choices. Does anybody understand this? Either positive 5 or negative 5. And the other number that you put in here is distance from 0, it's not going to be 5, it's going to be something else. Yes? So it's clear that once you reach this point, then there are two solutions, either x is 5 or negative 5. Okay? Right, good. How about number 2?
No.
Very good. So this one has no solution. In other words, solution set is empty. And the point is that absolute value means distance, and distance has to be positive or 0 if we're talking about the number 0. So in other words, when you have absolute value of something equals a negative quantity, that's impossible. That's never going to happen. Okay? So if you arrive to something like this, remember there is no solution. And this actually illustrates the way that you solve absolute value equations. If you have an equation containing absolute value, what do? Just move stuff around until you have absolute value by itself on one side, and on the other side, you're going to have a number. At that point, you use this property. Remember, x here stands for whatever is inside the absolute value. You just set it to either the number on the right or minus the number. And then you solve. You get two equations and you finish solving. Okay? Let me show you this in another example. But that kind of illustrates what's going on. So let's say that we have something like this. We want to take advantage of this idea. So the first thing that we want to do is we isolate the absolute value. Okay? So from here we get that absolute value of 2x plus 3 equals to 7. Okay? Now, the way to think about this is 2x plus 3 is some expression, which when x has a value, this will be a number, right? And what we're saying is that the absolute value of this must be 7. So there are only two possibilities for the stuff inside. What are they? It's either 7 or negative 7. There is no other choice, right? So from here you get that either 2x plus 3 equals 7 or 2x plus 3 equals negative 7. Those are the only two possibilities. Do you understand this? And now just solve each of them. So here we get 4, so x equals 2. And over here we get, what is this? Negative 10. So x equals negative 5. And, well, let's see, let me not be too quick in boxing stuff. So let's check. So if I put x equals 2 here, we're going to get 4, that's a 7. 7 minus 5, that's 2. Very good. So x equals 2 works. How about negative 5? If I put a negative 5 here, we're going to have negative 10. Negative 10 plus 3, that's negative 7. Absolute value, that's positive 7 minus 5, that's 2. So that's good. You know, most of the time when it's something small like this, you can just visually inspect it, okay? There's no need to actually do the computation unless the numbers are complicated and so on, and then, or large, and then, okay, you compute. But it's always good practice to check, okay? All right, questions? Let me put here 4. How about this one? Yes?
No solution.
No solution. Good. Why?
Because when you subtract 5 from 2, you get -3.
So if we do minus 5, we're going to get this statement, right? And then at this point, you need to. It's a ghost, right? So at this point, we have the following statement: the absolute value of something, whatever this is, equals a negative number. At this point, you stop. You say this doesn't make sense. Do you understand this? No need to continue trying to solve anything. This has no solution. So this is always false, regardless of x. So no solution. Okay, so always be on the lookout. So this property of breaking up the absolute value into two equations and so on is only if the number that you have on the right hand side is either 0 or greater. Okay, if the number is not negative. If you have a negative number here, you stop immediately and you say no solution. Of course, make sure that you know that this is the absolute value by itself here. I mean, you have a negative 2 here, for example. If you had a negative 2 in here, you wouldn't say that there is no solution, because when you add 5, then that will become a 3, and that's okay, right? So just when you have the absolute value alone, if the right hand side is negative, then okay, there's no solution. All right, so let me put the property just to have it written down. So property, let U be an expression and A greater than or equal than 0, a non-negative real number. So it's a real number that's greater than or equal than 0. Okay. Then absolute value of U equals A means that u is either a or negative a. Okay, so that's the idea you use. You have this kind of statement, that's how you break it up. You get two equations from there. And then we say, and the equation absolute value of u equals negative a, because a is non-negative, assuming that a is positive. When I put the minus, then I truly have a negative number here. So if this happens, then this has no solution. Okay, just summarizing what we just discussed. Questions? All right, so let me give you some more examples for you to try. Let's see examples. Solve. So we did 1, 2, 3, 4. So I guess number 5. Let's do 2 times 2 minus 3x plus 5 equals 9. Okay, so try this 4. Okay, maybe I can connect. Okay, so we are back to normal now. Okay, the first one. What do we need to do? What's the first step? So isolate the absolute value, right? So start 5 and then divide by 2. So we get absolute value. Okay, let me just do it one step at a time. So it's gonna be equal to 4, and then we get absolute value of 2 minus 3x. Here it's very important to leave the absolute value alone. So if you have something here, you have to divide. Okay, even if it's not gonna cancel, just divide. So it's gonna be equal to 2. Okay, what do we do now?
Split it into 2 minus 3x equals 2 and 2 minus 3x equals negative.
So we get two equations from here. We are removing now the absolute value, but if you want to remove the absolute value, you need to say that the stuff inside could be either positive 2 or negative 2. Okay? You have to give it the two possibilities. And now we finish solving. So from here we get negative 3x is equal to 0. So we get x is equal to 0. From here we get negative 3x is negative 4. So x is 4 over 3. So let's visually inspect. You put 0 here, this is gone. So you're going to get 2 times 2 is 4 plus 5 is 9. So this is good. You put 4 over 3 here, the 3 is cancelled. So you get 2 minus 4, it's negative 2. Absolute value is positive 2 times 2 is 4 plus 5 is 9. So we are good. Questions? How about number 6? Very good. Does everybody see that there is no solution? So even at this point, you can already say there is no solution because you have here 19 plus something that's never negative. There's no way you can get 5. Okay? So, no solution. But, you can do the little extra step of moving the 19 over. So what is that? Negative 14. And then right here you say, oh, a solution. That's impossible. Okay? Cannot have negative. All right. How about number 7? What do? So we move the 14 over, so we get absolute value of 2x plus 4 equals x plus 14. And so far we have been using the property with a number over here, but even if it's not a number, we can still do the same thing, okay? Because remember, for each value of x, when you plug it in here, you're gonna get a number anyways, okay? Now here is where you need to really be mindful when you're solving, okay? Because you could have solutions that do not work. For example, in the previous cases, I have been checking, but typically, if the only variable shows up inside the absolute value, and if you throw your calculations, whatever you get here, those are solutions, okay? They're gonna work. Now, if you have variables outside the absolute value, in this case, you have to be careful. It could be that you get solutions that do not work. So then you will need to check, okay? So, for example, here we have to check. In number 8, we have to check. Okay, so let's do it. So this means that either 2x plus 4 equals x plus 14, or 2x plus 4 equals negative x plus 14. Do you understand this? Okay, and now we have 2 little linear equations. Let's solve it. So what do we get? So x is 10, and then on the other one we have 2x plus 4 equals negative x minus 14. So that's 3x equals negative 18. So we get negative 6. Okay? So let's see. 10. That's 10 works. 20. That's a 24. 24 minus 14. That's 10. So this guy is good. How about negative 6? So that's negative 12. Negative 12 plus 4. That's 8. Then 8 minus 14. That's negative 6. So both of them work. So we're good. So these 2 guys are okay. But you have to check. Okay? All right. Any questions? Okay. So let's take a look at the next one. The next one is pretty similar. So, we do the same thing. Isolate the absolute value. Split 2 minus x equals 5x minus 4. Or 2 minus x equals negative 5x minus 4. And then we solve. So let's see, I'm going to move the 4 to the left. It's going to give me a 6. And the x to the right, that's a 6x. So x is equal to 1. And over here we have 2 minus x is negative 5x plus 4. Moving the 5x to the left, we get 4. 2 to the right, we have a 2. So we get 1/2. Okay, so let's go ahead and let's check. And let's see if this guy works. So we put a 1 here, that's okay, right? You're going to get 1. 1 plus 4 is 5. 5 times 1 is 5. So this guy is fine. How about this one, 1/2? If you put a 1/2 here, we're gonna have 3/2, and then 3/2 plus 4, that's 5.5, right? 5.5. If you put a 1/2 here, what do we get? 2.5. So this guy is not good. You understand this? So you have to be careful. So this one was okay. This one is not okay. So this is extraneous. So sometimes you will have extraneous solutions, sometimes you won't. Okay? The only way to catch them is by flowing in. And as I said, the problem is that we have this variable outside that is not part of the absolute value. So when we plug in something, things may not go the way we want. Okay, questions? Okay, good. So let's see, let me give you one more and then give you some time to try. Now play a little bit with fractions here. So let's see, what should be the first step here to make your life easier? Okay, if you bring the 2 over, you have to add or subtract fractions. If you are okay with that, that's fine. But remember, when you have a lot of fractions, what you should do is get rid of them to avoid complications. You made a mistake combining them and then you will be in trouble. So how can we get rid of those fractions? And you don't have to, you can just manipulate the fractions. But if it's good practice to get rid of them. So how can we do that?
Multiply by the greatest constant.
The LCD, the least common denominator, which is 6. So if you want to talk about factors, it will be the minimum common multiple, and not factors. Factors are always more. Okay, good. So here to make your life easier, the first thing that you should do is multiply by 6 every single term, just to get rid of all of these denominators. Okay, and then this problem will turn into one of the ones that we have been doing. Okay, and then it's easier to manipulate the expressions. So when we multiply by 6, what do we get? 3 cancel with the 6, giving you 2 times 2 is 4, plus 12 equals 21. Because 2 cancel with the 6, giving you 3 times 7, 21. Now, this is easier to manipulate than the previous one. Again, we're just doing this for convenience, okay? All right, so let's see. So what's going on here? You get 5 minus 7x equals, what is this, 9? And divide. So we get 9 over 4. Then we split into 2 equations, right? So 5 minus 7x equals 9 over 4, or 5 minus 7x equals negative 9 over 4. And then we solve. Again, I will just multiply by 4, okay? Just to keep it simple. So then this becomes 20 minus 28x equals 9. So negative 28x is going to be negative 29. So x is 29 over 28. That would be one solution. And then the other one, multiplied by 4, So what is this? Oh wait, 9 minus 20 is negative 11. So that's negative 11 over 28. And then the other one is a negative 29. And so we get 29 over 20. Negative 11 and then positive 11 over 20. Okay, questions? And again, really the concern is when we have variables outside. In this case, we didn't have variables outside, but it's fine, okay? Anyway, we go ahead and we plug in the solutions. For example, let's plug in the first one. If we okay, this equation is essentially equivalent to this one, okay? So let's check at this level. So if you plug in 11 over 28, so we're gonna get a 4 down here, so that's 11 over 4. So 5, that's 20 over 4. So 20 minus 11, that is 9. So 9 over 4 times 4, the 4's cancel, so you get 9. Plus 12, that's 21. So very good. Okay? And if you plug in this one, let's just do it. So you put it here, 29 over 28, so you get a 4 down here. So that's 20 over 4. So 20 minus 29, that's negative 9 over 4. But this gives you 9 over 4 with the absolute value. 4's cancel, 9 plus 12, 21. So we're good. In other words, you really need to concern yourself when there is variable outside the absolute value. Okay? In this case, we only have numbers outside, so if you trust what you did, you should be fine with your solutions. Okay, questions? Okay, so this is how we solve absolute value equation. There's really nothing more to this, so there's no point in doing more examples. The strategy is always the same. Okay.